Welcome back my students, Dr. Ugwe here, and today we are going to study the learning objective number 3rd from chapter 32 Guyton Physiology, that is list the effects of sympathetic and parasympathetic nervous activity on the conduction of cardiac impulse. No need to write anything, my handwritten notes are in the description of this video, and in this video we are also going to talk about the concept of ventricular escape. So let's begin with our topic, that is the effect of parasympathetic nervous system and the effect of sympathetic nervous system on conduction of cardiac impulse. Let's begin with parasympathetic nervous system. When we stimulate parasympathetic nerves or vagal nerves, there is a release of neurotransmitter called acetylcholine at vagal nerve endings, and this acetylcholine exerts two of its effects. Number first effect is it decreases rate of rhythm of SA node. Clear? And we know that SA node is responsible for the heart rate generation. When parasympathetic nervous system via acetylcholine decreases the rate of rhythm of SA node, which implies it decreases heart rate because SA node generates heart rate. What is the second effect of parasympathetic nervous system? Parasympathetic nervous system increases conduction time via acetylcholine. Now what is this conduction time? We know that impulses heart rate is generated in SA node. So SA node generates cardiac impulses. These impulses then travel to atrioventricular node, then to AV bundle, then to Purkinje fiber, and then to ventricles, and ventricles contract. Now the time taken by the impulse to go from SA node to ventricles is known as conduction time. And this acetylcholine increases this conduction time, meaning more time is taken by the impulse to go from sinoatrial node to ventricles. That means slow transmission of cardiac impulse. Clear? This transmission of cardiac impulse is known as dromotropy. Clear? Now, parasympathetic nervous system decreases, slows transmission of cardiac impulse. So parasympathetic nervous system is a negatively dromotropic factor. Clear? While as sympathetic nervous system increases this transmission of cardiac impulse. So sympathetic nervous system is positively dromotropic. Clear? So what are the two effects of parasympathetic nervous system? Parasympathetic nervous system releases acetylcholine at vagal nerve endings, and it results in two effects, that is decrease in the heart rate at SA node and slowing of transmission of cardiac impulse from SA node to ventricles. Is that clear? Now this is the theory part of what I taught you so far. Stimulation of parasympathetic nerves to heart, which are also called the vagi, releases acetylcholine at vagal endings, resulting in two effects. Number first is it decreases the rate of rhythm of SA node. Secondly, it decreases the excitability of AV junctional fibers, thereby slowing transmission of cardiac impulse into the ventricles. So parasympathetic nervous system is negatively dromotropic. What is written here? Decreases the excitability of AV junctional fibers. So when the impulses are generated in SA node, these AV junctional fibers, their excitability decreases. When their excitability decreases, then more time is taken by the impulse to cross this AV bundle to reach the ventricles. So conduction time increases, that is, there is slow transmission of cardiac impulse. Is that clear? Now, if we give strong stimulation to parasympathetic nervous system, clear? So if we give stimulation to parasympathetic nervous system, there will be these two effects. Now the case arises, if we use strong stimulation to parasympathetic nervous system, it results in same two effects, that is this and this, but to a greater extent. So what are these two effects? Clear? So when parasympathetic nervous system is excited but strongly, it results in the lot of acetylcholine release. This lot of acetylcholine decreases the rate of SA node so much so that SA node does not generate heart rate. Is that clear? So SA node's rhythm is decreased, but it is decreased so much that it does not generate heart rate because of strong stimulation of parasympathetic nervous system. So if we strongly stimulate parasympathetic nervous system, there is lot of release of acetylcholine and it will result in no heart rate generation from SA node by SA node. Either it will result in this or it will result in another thing. That is, in this case, the SA node keep on generating cardiac impulses, but the excitability of AV junctional fibers is decreased so much that these SA nodal impulses are not reaching the ventricles. So two things will happen. Either the heart rate will not be generated, or the heart rate will be generated but that impulses are not reaching the ventricles because of the decreased excitability of AV junctional fibers. Is that clear? So we can say cardiac impulses are not reaching ventricles. So if we strongly stimulate parasympathetic nervous system, these are the two effects that are going to happen, but they are extreme. And because of these two extreme conditions, heart will stop beating. Heart, or we can say ventricles will stop beating. Why the ventricles are not beating? Because SA node is not generating impulses, or if it is generating impulses, they are not reaching the ventricles. Clear? Now an interesting thing happens here. So heart is not generating, ventricles have stopped beating. After 5 to 20 seconds, so ventricles are not pumping the blood, our body is not getting the blood, the person will faint because his brain is not getting the blood. This Purkinje fibers, after 5 to 20 seconds, senses that I am not getting the impulses from sinoatrial node. So when Purkinje fiber, after 5 to 20 seconds, senses that I am not getting the impulses, this Purkinje fiber develops its own cardiac impulses. Clear? And give those impulses to ventricles so that ventricles will contract and human body will get the blood. Clear? So after 5 to 20 seconds, the person will faint, then he will regain his consciousness. Why he will regain his consciousness? Because Purkinje fibers are now developing its own impulses. Purkinje fiber was getting the impulses from sinoatrial node, and then Purkinje fiber was giving those impulses to ventricles. Now the Purkinje fiber is not receiving the impulses from sinoatrial node. Purkinje fiber acts its own boss, develops its own rhythm, and give those impulses to ventricles. Now the ventricles contract and human body gets the blood. Because of this phenomena, a person can survive, and this phenomena is known as ventricular escape. So how the ventricle escape from death? How the human body escapes from death? Because ventricles was not getting the impulses from sinoatrial node, so Purkinje fiber acts its own boss. So this is what I taught you, ventricular escape. These are the notes. So what are these notes? Strong stimulation of vagi can stop completely the rhythmical excitation by the SA node or block completely transmission of cardiac impulses from atria into the ventricles through the AV node. So the ventricles may stop beating for 5 to 20 seconds. So ventricles will stop. Then the small area in the Purkinje fiber develops a rhythm of its own and causes the ventricular contraction at a rate of 15 to 40 beats per minute. Clear? And this phenomena is called ventricular escape. Clear? So what is the normal pathway of the electrical excitation of heart? It is SA node to AV bundle to Purkinje fiber to ventricles. Clear? SA node generates 72 beats per minute. So it generates 72 cardiac impulses, and our heart beats, our ventricle beats 72 times. But when the Purkinje fiber, in case of ventricular escape, develops its own impulses, they are not 72 impulses per minute or 72 beats per minute. They are only 15 to 40 beats per minute. Clear? So when Purkinje fiber develops its own rhythm, those impulses are only 15 to 40 impulses per minute, and as a result, ventricles beat 15 to 40 beats per minute in case of ventricular escape. So these are the two effects of parasympathetic nervous system. That's first, it decreases the rate of rhythm of sinoatrial node, that is decreases heart rate, and it increases conduction time. Now moving on. Now we are going to study the effect of sympathetic nervous system on the conduction of cardiac impulse. Sympathetic nervous system exerts 4 effects, and they can be remembered as A, B, C and D. Clear? Here we will cut this A and replace the A with I. Now what is I? I is inotropic. Clear? B is bathmotropic. Clear? C is chronotropic. And D is dromotropic. Clearly, what is inotropic? It is force of contraction. Force of contraction. Sympathetic nervous system is positively inotropic. That means it increases the force of contraction. So atrias and ventricle contracts with a greater force. Clear? While as similarly, sympathetic nervous system is positively bathmotropic. What is bathmotropic? Bathmotropic means excitability. Clear? So sympathetic nervous system increases the excitability of heart. So it is positively bathmotropic. Chronotropic means SA nodal discharge. Clear? So sympathetic nervous system increases the SA nodal discharge. So sympathetic nervous system is positively chronotropic. Similarly, what is dromotropic? That is transmission of cardiac impulse. Sympathetic nervous system increases the transmission of cardiac impulse. So sympathetic nervous system is positively dromotropic. Clear? So we can say that sympathetic nervous system increases the overall activity of heart by being positively inotropic, by being positively bathmotropic, by being positively chronotropic, and by being positively dromotropic. While as parasympathetic nervous system is negatively inotropic, bathmotropic, chronotropic, and dromotropic. Clear? So this is the theory part. Sympathetic stimulation, it has opposite effects on heart to those caused by the vagal stimulation. Vagal stimulation is parasympathetic nervous stimulation, and we have positively chronotropic, positively dromotropic, positively bathmotropic, and positively inotropic. Then, in short, sympathetic stimulation increases the overall activity of the heart. Thank you very much. Your doctor here. Keep revising, keep studying. God bless you.